what I would like you to take note of right away is I had a little bit of change of heart when it came to the SOHCAHTOA stuff. I wasn't going to put it anywhere on here. I was going to kind of hope that you'd remembered it. But then at the last minute, something softened me up a little bit. So the way the directions and stuff are at the top are the same way they'll be on the quiz tomorrow. So you'll still have to be able to use it, but the actual letters will be there for you. So, as we did all along when we were dealing with these guys, I look first to see where my angle is, because that's going to base where my opposite and adjacent are. My hypotenuse is always going to be the same. It's always going to be the one that's across from the right angle, the longest side. But as far as the other two go, we'd always said, hey, if I start at the angle I have and just work my pen or pencil across, that would be my opposite side, which means the other side would be left for my adjacent. Once I know those, now I can figure out which trig function I'm going to use. Because I look for the two sides where I have a variable or a number at, which in this case is opposite and adjacent. There's my OA, which tells me I'm going to use tangent. So the tangent of 70 is opposite over adjacent. So once we have this set up, reminder, when x is on the top, it just means we're going to be multiplying my trig function and my value on the bottom together. So we've got 4 times the tangent of 70 degrees. Now, this shouldn't be a problem, but I'm not going to say that it for sure isn't. So, suggestion, when you get one of the calculators, make sure that you hit mode. Please make sure you are in degree. We are at that time of the year where my honor students are doing stuff in radians, so they may have switched it over, even though I told them to switch it back. So make sure you're in degree. Then I can go ahead and type in my values. And just like before, we're typically just going to round to the nearest tenth. Well, in this case, the nearest tenth, if I round up, is just going to go to 11. So that would be my answer. Okay. If you wrote like 10.99 or something, I wouldn't mark it wrong. Okay. But don't, start doing a whole lot of extra rounding that isn't needed. And so basically, on these, that's what I'm just going to keep doing. I'm going to keep being like, all right, there's my hypotenuse. There's my opposite, which leaves this for my adjacent. And I keep looking for those two sides where either a variable or a number is. I got adjacent and hypotenuse. Look for my AH. So that'd be cosine. All right, thank you. So, this time a little different. This time the x is in the denominator. So what that means is I'm going to be dividing the 5 by my trig function. And we've talked before about how you can do it algebraically too. It's fine, it just takes a couple of steps. But for our purposes, we're going to kind of keep jumping in this way. I'm trying to avoid the glare, but I'm not having very good luck. So here, 5.77, we'd probably just go to 5.8. But if you want to write out more decimal points, you go for it. And again, my answer in this case makes sense. Well, what do you mean it makes sense? Since I was looking for the hypotenuse, it better be at least longer than the one side that I already have. Like if I'd have gotten like 4.8, that wouldn't have made much sense. It probably means I did something wrong. But that one seemed to work okay, so we're good. Okay. 3, there's my angle. My hypotenuse, there's my opposite and my adjacent. And once again, sort of like number 2, it looks like I've got the adjacent and the hypotenuse. So once again, I have the cosine. So, adjacent over hypotenuse. Same setup even. X is on the bottom, so we're going to end up dividing the 9. By the cosine of 27. It looks like we end up at about 10.1. So for angles, it's as straightforward as that. Type in my fraction, get my little bit of setup done, I can just punch it straight in. Now when it's an angle, it changes a little. This little circle with the line, theta that we talked about, that's still the angle I'm basing everything off of. So I still want to label my sides. And I still am going to use that to figure out which trig function I'm using. So here I have O and A, opposite and adjacent, which would be tangent. But remember, when we're doing angles, this is the one where I have the -1. The one where once I get this set up, I need to hit second and tangent, or whatever trig function it is, to get that little -1. And then I just type in the fraction that I got, and that'll get me my angle measure, which in this case looks like it's about 35.6. Yeah, if you went to the nearest whole on a degree, there is no problem with that. And then the same thing for 5. Got my hypotenuse, got my opposite and my adjacent. This time I got opposite and hypotenuse, so we got some sine working, but we're still looking for an angle. So we'll get that written in. And again, theta, if you go to tenths, we'd have to be at 15.7. If you go to whole, we're at 16. Okay? Either of them, perfectly peachy. So just keep those sides straight. Shouldn't be too bad of a deal. So then we get to our applications. So we got a building casting a shadow of 70 meters when the angle of elevation of the sun is 50 degrees. How tall is the building? Now my sketch is kind of important here. The building casts a shadow of 70 meters. Some of you were talking to me about this. Think about when you're standing outside and you see your shadow. Okay? Your shadow is not hovering in midair. It is not like a 3D hologram. It's on the ground. So when we talk about shadows, they're going to be on the ground, on my horizontal. Angle of elevation. We really don't care about this word because I know my angle is going to end up down here either way. Unless you have a picture where the angle is up here, your angle will be down here. How tall is the building? And now everything runs just like it did on the ones in the front. Hypotenuse, opposite, adjacent. So I've got, let's see here, I got opposite and adjacent. Sounds kind of tangent-y to me. Opposite over adjacent. The fraction's the same order that it is, in the TOA part. X is on top, we multiply. Keep it simple, keep it simple, keep it simple. So let's see here. 70 times the tangent of 5. Whoa, not 5. So X is about 83.4-ish meters. Which again makes sense. It's longer than this other side. Well, not so much when it's the opposite. It wouldn't have to be. So scratch that. Harty error. It only took 9 minutes for it to happen. So we got another one here. They're all going to be right triangles, so we can just go ahead and do that. You lean a 20-foot ladder against a wall. When you think about leaning a ladder against a wall, it's normally at an angle. So, makes sense. My 20 would be out here. If the base is 6 feet from the wall, so here's the bottom of my ladder, here's the wall. So if the base is 6 feet away, there's my 6, what angle does the ladder make with the ground? And if you'd rather use X instead of theta, you can. Doesn't hurt anything. Otherwise, same deal. Label my sides. See where my two numbers are at in this case. Adjacent and hypotenuse, which is cosine. I'm looking for an angle. So I've got to hit second with my cosine. And either 72.5 degrees, or if you're rounding and you went to 73, that's fine. Even though right here it says round to the nearest tenth, so I'd probably just read the directions, which I just noticed I did not do on number 6. Oh, mercy, Harty. All right. Last one here. A kite has a string 200 meters long. Now, we've talked about one like this before. When you think about a kite, you're like, okay, so this kite's flying. It's got to be one of these. How often do you see a kite straight vertical? You don't. So, my 200 would be over here. The string makes an angle of 43 degrees with the ground. Determine the height. So, hypotenuse, opposite. Okay, I got both now. I got my variable, got my number. OH is sine. Okay, not second this time because we have the angle measure. X is on top, means we multiply both sides. And we end up 136.4. And get my solution. Okay, so just draw a right triangle. Don't try to be cute. You don't get bonus points for having the coolest artwork. Just got to kind of work it a little bit. All right. Now to what we were doing yesterday. Convert each of the following degrees to radian measure. Radian measure, meaning pi is involved. Whenever we want pi to be involved, we want pi on top. So, pi over 180. And as we talked about, when I multiply straight across, I'm not leaving it this way. I can reduce the coefficient part. Leave pi alone, because that's the essence of radian, is that there's pi there. So I get a fraction of 19 over 18. So the 19 stays on top with my pi. The 18 goes in the bottom, and I'm good. Okay, but pi's got to be on top. Even if you wanted to, I might even not even have to multiply across here. I just know 300's on top. 180's on the bottom. Math, enter, enter. 5 over 3. 5 pi over 3. Negatives? Doesn't matter. Same thing. Just make sure you don't forget about the negative. Negative 105 divided by 180. Negative 7 pi over 12. And we're set there. Okay, so degree to radian, make sure pi is on top. Convert each of the following radians to degree. Degree measure, we want no pi. So how do we take care of that? We do the opposite of what we were doing up above. Instead of doing pi over 180, we're going to do 180 over pi. Why? Well, because in this situation, if I were to multiply across, I notice, hey, I got a fraction. Pi's cancel. That's what I want. And then 180 divided by 3 is 60. No pi. I'm in degree mode. Awesome. So for any time that's asked, if it's not a fraction, make it 1. Pi's cancel. Punch 2 times 180 into the calculator. So you can kind of see what I mean when I say this should be the easiest quiz, basically, of the semester probably, just because it's some real basic things that we're doing, not a lot of steps. A little bit of practice, we should be good. And then finally, now here, there's a little more thought. I would go ahead at this point and multiply across once I canceled the pi's out. And then type that answer into the calculator. 540 divided by 4. Which would be 135. So degree measure, no pi, radian measure, gotta have it. And finally, the only place that I was not nice on this whole thing. Okay, central angle of radian measure theta intercepts an arc length S on the circle with radius R. Find S. Okay, this whole formula. No, I'm not putting it on a board. No, I'm not telling you at the start tomorrow. No, it's not going to be on the quiz. If we can't remember radius times angle, or r theta, yeah, okay? So then I got to look to see what information I'm given, because that's going to make a difference. So here I see that I've got r, and I have theta. So all I have to do is multiply them together, because that's the information I have. That's what I'm trying to figure out. So 8 pi over 4, remember, don't touch the pi. 8 divided by 4 is 2. So 2 pi. Or if I want to be really good, 2 pi centimeters. But then I throw a curveball at you. Could I throw a curveball tomorrow? I could. So be wary. Okay? Find theta. Ooh. If my arc length is 27 and my radius is 9. Okay? Theta is just like a variable. It's just like x would be or anything like that. So treat it the same way. Okay, I want to get theta alone. I'm multiplying it by 9. What's the opposite? Divide it by 9. So theta equals 3. Okay. So don't just assume it's always going to be multiply them together. You got to read carefully. I might switch the order around. I might have you solve for r. I could do all sorts of good stuff. So this is the quiz. So as you can see, about 15 minutes, a little more. That's about all it should be. So it's going to give you plenty of time if you need to clean some stuff up for a homework check. If you need to take your time on it, if you need to work on something from like a retake on the probability, you can do that. But make sure that you've done some things, and hopefully this isn't the only thing you've done in the entire section.